The huge amount of water vapor hurled into the atmosphere, as detected by NASA's microwave lens sounder, could end up temporarily warming Earth's surface on January 15 of 2022. The Hong'e Tonga Hong'eha, a pai undersea volcano erupted, ejecting enough water into Earth's stratosphere to fill 58,000 Olympic-sized swimming pools. This is according to a NASA study published in the journal Geophysical Research. Letters we've never seen anything like it, said Luis Millan, an atmospheric scientist at NASA's Jet Propulsion Laboratory in Southern California. He led a new study examining the amount of water vapor that the Tonga volcano injected into the stratosphere, the layer of the atmosphere between about 8 and 33 miles 12 and 53 kilometers above Earth's surface. Previous major volcanic eruptions, like Mount Pinatubo, Mount St. Helens and the much earlier mega eruption of Krakatoa, have led to a cooling effect on Earth's weather as ash and other particulate matter ejected into the atmosphere combine to reflect the rays of the sun back into space. However, in the case of the Tonga blast, the caldera was situated nearly 500 feet below the surface of the South Pacific Ocean, resulting in a muted particulate ash cloud, but a greatly enhanced vaporizing of the surrounding water, ejecting that vapor into the stratosphere, where it will have the effect of trapping heat on the Earth's surface. Measurements from the microwave lens sounder on NASA's Aura satellite indicate the excess water vapor is equivalent to around 10% of the amount of water vapor typically residing in the stratosphere, where this excess stratospheric H2O will persist for years, could affect stratospheric chemistry and dynamics, and may lead to surface warming. This estimate, conducted in late 2020, has been recently revised upward from a 10% increase in stratospheric water vapor to a 30% increase by the European Space Agency. Water vapor is a well-recognized greenhouse gas, whose heightened presence leads to higher surface temperatures, a mechanism much more powerful than the interaction of atmospheric CO2, as explained by the NASA Jet Propulsion Laboratory. Volcanic eruptions rarely inject much water into the stratosphere. In the 18 years that NASA has been taking measurements, only two other eruptions, see the 2008 Kazat-Okai event in Alaska and the 2015 Calbuco eruption in Chile, sent appreciable amounts of water vapor to such high altitudes. But those were mere blips compared to the Tonga event, and the water vapor from both previous eruptions dissipated quickly. The excess water vapor injected by the Tonga volcano, on the other hand, could remain in the stratosphere for several years. This extra water vapor could influence atmospheric chemistry, boosting certain chemical reactions that could temporarily worsen depletion of the ozone layer. It could also influence surface temperatures. Massive volcanic eruptions, like Krakatoa and Mount Pinatubo, typically cool Earth's surface by ejecting gases, dust, and ash that reflect sunlight back into space. In contrast, the Tonga volcano didn't inject large amounts of aerosols into the stratosphere, and the huge amounts of water vapor from the eruption may have a small, temporary warming effect. Since water vapor traps heat, the effect would dissipate when the extra water vapor cycles out of the stratosphere. Emphases added the likelihood of our present warming trend owing to this dramatically increased, entirely natural greenhouse effect of water vapor from the Tonga eruption has been admitted to by the two major space agencies, NASA and the European Space Agency, yet has remained largely unreported in the media.